Hello everyone, my name is Anton Tingström. I'm the lead iOS developer at Viaplay. And I'm here to talk to you about automated UI testing, because manual testing is really boring, to be honest. In this session, I'll talk about the state of automated testing today, what led up to this presentation. I'll talk a bit about what UI testing is, conceptually, and then how you can use it in practice. Talking about the state of automated testing. If you guys were into automated testing a few years ago as a Mac or iOS developer, you know how bad it was. There was no integration in Xcode, and the tools were really poor, and nobody really using them. So there's no community around testing, or was no community around testing. But that has slowly improved over the years. A few years ago, Apple started embracing testing as part of what they're doing in Xcode. We got a test navigator in Xcode, which allows us to see the status of our tests and a quick overview of the tests we have. We got support for asynchronous testing, which is, we do asynchronous stuff. We need this. It's elementary. We got support for doing performance testing to make sure that the code we're actually running is, not slowing down when you're fixing bugs and doing things with it. We got Xcode server, which allows us to do continuous integration of your tests, have them running all the time, and make sure to catch errors from you and your team members. And if you're not into Xcode server, which has gotten some criticisms, you can use Xcode build to run your tests on the command line and therefore set up your own continuous integration solution. Now, this has been all good, but this has actually been focused on one thing, which is unit testing. There has not been support for UI testing at all. And this has now changed in Xcode 7. Xcode 7 features new APIs for doing UI testing. Now, you may ask, what is UI testing really? Well, UI testing allows you to automate your manual testing. So think about, when you're doing manual testing of your applications, what you're actually doing? Well, you're doing one thing, which is navigating around your application. And doing another thing, which is you're making sure the things are appearing as you expect them to appear, and that they behave the way you expect them to behave. And UI testing gives us APIs to do these kind of things, but with code instead of, poking around the application with your fingers. So we have APIs for retrieving elements from our screen to inspect and see what we're actually having on our screen and interact with those elements, and then validate your properties to see that they are what you expect them to be. Now, I will show you later in a few examples, and this hopefully makes a bit more sense if you're not following. Now, before that, the requirements. What do we need to do UI testing? Well, we need iOS 9 or macOS 10 El Capitan. And this is because it relies on some new OS features that Apple has created. So it's not backwards compatible, unfortunately. It works with both simulators and devices running iOS 9. And you can use how many you want, iPads, iPhones, simulators, mix and match, do whatever you want. Everything works. And this is a big must, your app must support accessibility. Because the UI testing APIs use the accessibility APIs of iOS or your Mac to retrieve the elements on your screen. So if you haven't added accessibility labels to your standard UI kit components, now is the time to do it. If you haven't implemented accessibility support for your custom components, this is the time to do it. Your users will be happy because you have accessibility, and you will have a much more easier time writing your UI tests. Now, when we're doing UI tests, there are actually three main APIs we need to know about. The first one is the XCUI application. Now, this object represents your application that you're going to test. And this allows, using this API, you can then launch and terminate your application. You can also use the app to retrieve your elements, which are basically the things you see on your screen. It's your table views, it's your cells, it's your labels, it's your buttons. All the things you are familiar with from UIKit are there. And to retrieve these kind of elements, we're going to use an XCUI element query. Now, the queries allows you to find these elements by name or by index or any means you want. And you can go nested, so you can find, I want to find the label inside the cell, inside the table view that's inside my view controller in the tab bar. So you can drill down how deep you want, or just go, I want any label with this name. So, how do you use this in practice? To show this, I'm going to introduce to you a very new, very real app. Apple Music has gotten a lot of criticism because it's buggy. So I thought I'm going to one-up Apple. I'm going to create Banana Music. Now, Banana Music is the world's most hand-picked curated service. It only has 4 artists: Nickelback, Venga Boys, Bass Hunter, and Westlife. So with Apple Music, you get the best music for you. With this app, you get the best music, period. Not. And this is basically the application. You have a login screen with a beautiful banana and a username and password field, a login button. And when you have logged in, you will access the library of wonderful music. So unfortunately, because I want to beat Apple, I have rushed this application a bit, which means that there are quite a few bugs in my application. So instead of doing a manual test, which is boring and I have to do it over and over again every time I make a new release, we're going to write some UI tests for this instead. Now, UI testing is really good for actually trying to catch edge cases. The cases that you're not realizing that there are issues with because you're not using them every day. So in this case, we're going to create a test for showing an alert when I input the wrong password. It's going to say, wrong password, hint, you probably use the same password everywhere, and the user has to press a button that says, shame on me. So how do we do this? If you have been using XUnit to write unit tests before, this is going to be really familiar. First, you need to grab your application, because we're going to use the application to retrieve your elements. Then, on the application, or any element, there's always convenience methods you can use to find elements of a certain type. So first, we're going to try to grab the username text field. Then, much like a user wants, you have to tap it before you type into it. That's going to show the keyboard, so we can then type text to it. I'm going to input my name, which is the username. Then we're going to do the same thing with the passwords. And notice that I specified I want a secure text field here. This means that the test will fail if I manage to make my password field not secure. So it will only find the elements of that specific type. Then we're going to find my login button, which is name login, and tap it. Now these tests are very straightforward. These steps in the test are very straightforward. And that's because everything is already on the screen. All the elements are there, and we can just tap and interact with them whenever we want. But because the Banana Music app has to connect to the highly secure Banana Music account servers to verify your credentials, we need to wait for an alert to show up. And this can take a bit of time. It will not authenticate directly. So what we need to do here is to use the asynchronous testing APIs as part of XUnit. So we're going to retrieve the alert. Now the alert doesn't exist, but the UI element objects, XUI element objects, are just placeholders. So you can actually create one for an object that's not on screen at this moment in time. And then we're going to create a predicate, because I want the alert to appear. So we're going to check that it exists. Then we're going to create an expectation for that predicate and wait for the expectation to happen. So let's run the test and see what happens. Now, it's going to select the username field. It's going to type very quickly my password, press the login button, and nothing happens. That's a bit disappointing, right? I think we have a bug here. Let's go back to Xcode and see what happens. And yes, indeed, in the very small, tiny warning text, you can see that it said that the asynchronous wait failed. Exceeded timeout of 2 seconds with unfulfilled expectations. Now, because you guys saw the test run, this is really obvious what's wrong. The alert never appeared. So let's go ahead and fix the bug in my application, and then we can simply rerun the tests. It's going to enter the credentials. It's going to press the login button, and voila, we have the alert. So now we have already caught one bug in the application, and we have a good test case so we can make sure that this bug never reappears in the application. Now, the next step is that when you log in, I want to make sure that you can access the library of the wonderful 4 bands we have. So, setting up the test, first we're going to have to log in with credentials, and in this case I have refactored the login code into a new function so we can reuse these steps over again without having to copy-paste. And then comes the interesting part. We're going to wait for the library to appear, but then when the libraries have appeared, we can then start inspecting it. Now, if you have been using XUnit before, you're going to notice one weird thing about my last test. I never actually created an explicit assertions. I used to retrieve the elements, I used to tap on them, I used to type on them, I just waited for them to appear. And this is because XUnit and the UI testing APIs actually creates implicit assertions for you. So if you try to interact with an element that's not on screen, the test will fail. So just by navigating through your application, you will actually perform a lot of assertions and checks in, as in your test. But we can also do like explicit standard unit testing like assertions. So we can, for example, in the library, we can retrieve the cells we have and then see how many we have. And because we have 4 hand-picked band, we expect them to show up. And if you're making a real-world application, you might have a dynamic set of data. When you're writing UI tests, it's highly recommended by Apple to actually feed your app a static set of data. So you can then do these kind of assertions where I expect this to be a certain amount. And then, as you see in the next assertions I do in my test, we can assert that the things we have on the screen are actually what I expect them to be. So I look inside the library and make sure that the first label is going to be Nickelback, then the second label is going to be Venga Voice, because it would be horrible if we had Venga Voice before Nickelback in our application. So now we can run this test and see what happens. So we're going to log in once more, using valid credentials this time. And then, wow, one more bug. That's really bad. I mean, this application is no good. Let's see what happened. Well, this time we actually got another failure, which is a bit more vague, and that's because my assertion failed. It said that XCT assert failed, only 4 bands should be shown. Now, we all watched the test, so we know what went wrong. The library was empty. And this shows why it's good to actually assert that the things, not that element just appears, but they actually contain the right things. Because if I only had asserted that the library would show up, then this test will pass, even though the application is not working as intended. Now, because we were watching the test run, we know what's wrong. But in many cases, you're not watching your tests run. Maybe you're having a coffee from the disgusting coffee machine in your office, or most likely, maybe you have a continuous integration solution, which is continuously running your tests all day long. This means that when your test fails, you're not there to see what went wrong, unless you're a crazy person and watching the test run all day, which is really boring. So what we can do is in Xcode, we actually have the test report. Now in the test reports, we can see all the steps that was performed as part of the tests. So the code you have written turns into actions, and here's a list of those actions. Now it's a bit hard to see, but if you hover your mouse over the last step, you're going to see one of those quick look eyes. If you press that, we're going to get a screenshot of the application in that state, which means that you can debug why your test failed after the test is running. Of course, you can always rerun the test locally, but it's good to see what went wrong when the test actually failed in that time. So now we can easily fix the bug, because we know what went wrong. We're going to rerun the test. It's going to log in with some valid credentials, wait for the library to appear, and voila, it contains the things we expect it to be. So now we're starting to get into shape. This application is actually having the features we promised it would be having. Now, there's one more test I want to do, which shows the power of XC UI testing, which is login persistent. Because we are controlling the app, we can test things that are happening across relaunches of the application. So for example, the first launch, we expect the app to show the login screen. But if you have entered your credentials and you relaunch the application, we expect you to be able to access the library immediately. Now we can easily test this, because what we can do is we're going to log in with valid credentials, and then because we are controlling the execution of the app, we can terminate it. Then we can relaunch it, and then assert that the library appears as we expect it to be. So let's run the test and see what happens. So we're going to enter some credentials to the app. We're going to log in. Then it's going to kill the app. It's going to relaunch it. And yes, we're on the library. Finally, a feature that worked on the first time. I'm so happy about this. Now, there are so much more features as part of the UI testing in Xcode 7. We can generate test code using the UI recording feature. You don't have to write everything manually. There's a tool that allows you to click around in your application, and then it's going to generate the test code for you. And this is a good way to create the bulk of your test and then fill in with the specific assertions you want it to have. You can run tests on multiple devices and simulators at the same time, especially if you're running Xcode server, which is a really good way to make sure that across all the different screen sizes and devices we have now these days, your app works as intended. And you can use Xcode Server for continuous integration. So Xcode Server, as the new one you can find on the developer portal under the beta section, supports UI testing as well. If you're interested in learning more about testing, There's 3 really awesome sessions from WWDC. We have session 4.9, which is testing in Xcode 5, which is going to cover some unit testing basics and maybe why you should test and how you should test. We have session 4.1.4, which covers asynchronous testing and performance testing. And then we have this year's sessions 4.6, which is going to cover UI testing in Xcode, which is basically a more in-depth version of this brief presentation. Yeah, that's it about UI testing. Thank you for listening. Any questions?